Hey everyone, welcome to this video. We're going to do some review for angles and different types of angles, stuff from middle school and SM1. And then we're going to introduce proofs. If you're watching this on Canvas or if you weren't in class or anything like that, this paper that's uploaded to Canvas, okay, these are the properties of equality. Not just equality, but different properties of algebra. You're going to want this paper because when we take the quiz on this stuff in class, you get to have this paper. I give you one copy, and if you don't hold on to it, then I'm sorry, I just have the one copy for you. All right, so make sure you have this. Make sure you know where it's at. We're going to be using this today, too. Anyways, let's review some angles real quick. So definition of an angle, the one that we're going to use, two rays that have the same vertex. So these are rays, they have the same vertex. This is an angle. We measure angles using degrees, right? So we can say this is 45 degrees. All right. So I'll write the definition over here. Two rays that have the same vertex. Okay, that's what an angle is. That's not how you construct an angle. You construct an angle by making a ray and then rotating it. But we're not worried about that right now. We'll do that in SM3. Some different types of angles. So there's three types of angles that refer to the angle measure. We have acute angles. Now this is review, so you probably all know this, but it's good to review. Acute angle is an angle that's less than 90 degrees. Obtuse angle is an angle that's greater than 90 degrees. It also means, never mind. And then a right angle. One of my mom's favorite words to call my dad is obtuse, because it kind of means like you're being a butthead and you know that you are, and you're just doing it to mess with the other person kind of thing. So my mom loves that word, obtuse. A right angle is equal to 90 degrees. And when we draw a right angle, the notation we use is this little square here. Okay, the reason we use a square is because a square, all the angles are right angles. All the angles are 90 degrees. So it's fitting that we use a square to represent a 90-degree angle. There's some other ones. There's, complementary angles. How do you spell that? Complementary angles. Those are angles that add to 180. Add to 90 degrees. Supplementary. Those are angles that together their measure add to 180 degrees. So those are the types of angles in reference to angle measure. Now we're going to look at some types of angles in reference to their relationship with other angles. So let's see here. We have adjacent angles. So these two angles are adjacent. Adjacent angles are two angles that share a common side or a common ray. Notice that this right here, this side right here, is part of this angle and part of this angle. They share a common side. Those are adjacent angles. Adjacent. Then we have vertical angles. So vertical angles, two lines that intersect. This angle and this angle are vertical angles. Okay, you can kind of think of it. I know I have a definition here. They intersect at a point. They form four angles. They're non-adjacent angles, okay, which is a perfect way of thinking about it. The other way of thinking about it is that they're a reflection of each other. Notice that's kind of a reflection. So then these two right here are also vertical angles, a reflection. Let's see, some other angles that we need to remember or to review. Let's draw a couple parallel lines. Okay, now I know the definition that you've been told before. Parallel lines are lines that never intersect. That's true, but the formal definition that we use most of the times in Euclidean geometry is two lines that are equidistant apart, meaning they're the same distant. There's a bunch of definitions, okay, but that's the one that tends to get used the most. But because of that, they don't intersect. And then we have something here called a transversal. So a line that goes through the parallel lines. And we're going to look at alternate interior angles. So alternate interior angles. Interior means inside, so we're looking inside the parallel lines. Alternate means opposite or switching. So inside the parallel lines, the angles that are opposite side of the transversal are alternate interior angles. Okay, these angles are congruent, meaning the shape is the same and the angle measure is the same. They're not the same angle, okay, but their shape is the same. That's what we'll go with. Then we have alternate exterior angles. Let me draw that in a different color here. We have alternate exterior angles. Alternate exterior angles are similar to alternate interior, but it's exterior, outside of the parallel lines. So this one right here is outside the parallels, outside the parallels. So alternate, meaning switching sides of the transversal. Exterior means outside of the parallel lines. So these are alternate exterior angles. So are these. Alternate exterior angles are congruent, and their angle measures are equal. Then we have, let me erase this and we'll do another one. Oh, I forgot to tell you. Vertical angles. I know I already said this, but vertical angles, these right here. Vertical angles are also congruent and have equal angle measure. Okay. Sorry, the black is running out. Let's see here. Let's do a couple more. We need parallel lines again. So we have consecutive angles. Consecutive. So consecutive angles, another word that you probably heard that was probably used instead of a consecutive, are same side interior. So that's another word, or I guess phrase. Same side interior. You might have heard that one instead of consecutive. Either one, you can say either one, I don't care. I was taught consecutive, that word, so that's the one I think of first. But like I said, another way of saying it is same side interior. What that is are these two angles right here. So if you think of it as same side interior, it's inside the parallels on the same side as the transversal. So these two right here. Okay, the relationship between them is that consecutive angles, they have to add to 180 degrees. And then we have corresponding angles. So we'll say this one and this one. So corresponding angles, they're on the same side as the transversal, but alternating inside-outside of the parallels. So notice that these are on the same side as the transversal, but one's inside the parallel, one's outside. Okay, corresponding, they are congruent and equal angle measure. That's pretty much it for as far as angles. You might be asking, oh, why do we know this? That's actually what we're going to get into later on next week. Is we're going to prove some of these. Right? We're going to prove why our corresponding angle is equal or congruent. Why are consecutive or same side interior angles? Why do they add to 180? Right. One last definition we need to talk about. Sometimes supplementary angles, like this, these are supplementary angles, right? This line is 180 degrees. There's two angles here. Together they add to 180. This is called a linear pair. They add to 180 degrees. When you have two angles that add to 180 on the same line, say linear pair. Do not call them supplementary. Okay? Because they are a linear pair. Supplementary angles are usually used for two different angles that add to 180, or three or more angles on the same line is when we use supplementary. Okay, let's look at this first practice here, right here. So we have parallel, parallel, transversal. This is 70. We want to find the angle measures for each of these. Now, you need to state why. Okay, you have to prove everything now. From here on out, you got to prove it. You got to tell me why. You can't just give me an answer and I accept it. So B is 110 degrees because of linear pairs. Right, look, B is right here next to 70. It's on the same line. It's a pair of angles. They have to add to 180. Right, it's on the same line. They have to add to 180. Well, 70 plus 110 is 180. C is 110 degrees because of vertical angles. Right, this angle is a reflection onto here. They're non-adjacent angles. It's a reflection. So C is 110. Vertical angles are congruent. Now, an answer I would also accept is linear pairs. Because right here, 70 and angle C are on the same line. They're linear pairs. That's the nice thing about proofs, that it gives you freedom. It's not like PEMDAS with solving, where you have to do it in a hierarchy, right? You have to do it in that order. Here, it doesn't matter the order. You get to decide. So it gives you a lot more freedom. Angle D. It's 70. And I'm going to say it's 70 because of vertical angles. Right? 70 and 70, vertical angles. It's reflected on itself. E. I'm going to say it's 70. It is 70. But my reasoning is same side interior angles or consecutive angles. They have to add to 180. Consecutive angles. Let's see. A, B, C, D, E, F. Is 110. The reason I'm going to use is alternate interior angles. Remember, alternate interior angles are congruent. So if this is 110, this has to be 110. You could also use linear pair. You could use corresponding angles. G is 110. And I'm going to say because of alternate exterior angles. Right? Exterior, outside of the parallels, on opposite sides, on switching sides of the transversal. They're congruent. And then H is 70 degrees. And I'm going to say because vertical angles. Right? These angles are congruent, vertical angles. There's that first practice problem. We got another one here. It's very, very similar. You should probably pause the video and try this on your own, but I'll give you the answers here. Do it with you. 154 1, 2, 3, 5, 4, 6, 7. So angle 1 is 26 degrees because of linear pair. This is 26. Angle 2 is 154. And I'm going to say because of vertical angles. Angle 3 is 26 degrees. And I'm going to say because of vertical angles. Sorry, give me a second. I'm making sure that my computer's still on. Yeah, there it is. Angle 4 is 26 degrees. I'm going to say because alternate interior angles. Angle 5 is 154. I'm going to say because corresponding. 154. Corresponding. Angle 6, 154, because of vertical angles. Angle 7, 26, because of vertical angles. Okay. All right, let's go to the third page here. We have some parallels. We have this and this. This is 32 degrees, 115 degrees, 4, 3, 1, 2. So angle 1, measure of angle 1. Well, these are alternate interior angles, right? Here's my transversal. Alternate interior angles. So angle 1 is 115 degrees because of alternate interior angles. They're congruent. Angle 2 is 115 degrees because of vertical angles. Angle 3 is 148 degrees because of consecutive angles. Right? This angle plus this angle has to be 180. Here's my transversal. Here's my parallel lines. Same side, interior, 32 plus this has to be 180. So 180 minus 32 is 3. Or 180 minus 32 is 148, which is angle 3. And then angle 4 is 32 degrees because of linear pairs. Obviously, there's other answers here. It's okay if you got other answers as long as your angle measures are correct and the reasoning behind them is correct. There's just too many answers to do in this video if you want to keep it short or shorter. Okay, this next one. We want to find what x equals to on this next one. What x equals. Okay. So I know that angle 6 has to be 45 degrees because these are vertical angles. Thus, because this angle and this angle right here are consecutive or same side interior, they have to add to 180. So I'll add them together. 5x plus 35 plus 45 has to equal 180 by definition. 35 and 45 is 80. Yeah, x by itself, subtract 80 from both sides. Divide by 5 both sides. X equals 20. There's your answer. Okay, some Uno proofs, and it just dawned on me that I have a black and white copy, and for Uno, I need colors. So give me a second. Let me see if I can pull it up on my computer. You can just fast forward through this, I guess. Does it keep, I don't know if it'll keep recording, but I have it right here. Okay, here we go. So we're going to introduce proofs by using an Uno cards. A proof. The way I like to say it, and like I said, there's a quotation right here. I forgot to put who it's from. I forgot to set my sources. I'm sorry. But it's really cool. I like how they say it. Proofs are stories that convince suitably qualified others that a certain statement is true. So what a proof is you give a statement similar to a hypothesis in a different science, and using facts that you know to be true, things that have been proven prior that you know for a fact are true. Using those facts, you either prove or disprove that your statement. You either prove or disprove your statement. All right, and that's what we're going to practice. Now, we're not going to be doing real proofs. We're basically going to be doing outlines. All right, that's going to be much easier. But it is a new way of thinking. And as much as with proofs, every single thing you do, there has to be a reason that you're allowed to do that. So even the little tiny steps you do in your head that you normally don't think about, you just do it reactionarily. Is that a word? Anyways, every single step, even the little ones you do in your head without thinking, you have to put on paper and prove and say, why are you allowed to do this? What theorem, what proof, what previous truth am I allowed to quote in order to say that I'm allowed to do said step? And this will make more sense as we go along and work on this. What we're going to be using to do our proof outlines is this two-way chart. We have something called a statement on one side. So that's our statement. That's what we say is true. And then we have our reason on the other side. Why we're allowed to do this, why we're allowed to say the statement is our reason. Okay. And like I said, we're going to be using Uno proofs. Now, if you're watching this online, sorry, I got way up close without kneeling down. If you're watching this online, you have the colors there. I printed these off the day of, and I completely spaced that it was a black and white printer instead of color. So I know you don't have the color, but if it's online, you do. So just get on Canvas, pause the video, go look at the different colors. Okay, but with an Uno proof. So we're given a blue 8, and we want to prove, or we want to get to a yellow 3. And the cards we're allowed to use, or the cards we know to be true in our hand, are a green 1, a yellow 1, and a green 8. Okay, so we start with a blue 8. So I'm going to say my statement is I have a blue 8. The reason, that's what's given to me. That's my reason. That's the statement that's given to me. Now, in Uno, remember the rules are. This is the rules. I don't even know if these are like. I've never read the rule paper, but this is like the common ones I know. You're allowed to put the same colors on top of each other, or the same number, or a wild to switch the color, right? So, if I have a blue 8, of the cards I have in my hand, what can I put next? Well, green is not blue. 1 is not 8, so I can't put that. Yellow is not blue. 1 is not 8, so I can't put that card. Green is not blue, but 8 is 8. So I can put a green 8 next. Green 8. The reason for that is because they're the same number. Right? I'm allowed to put the same number on top of each other, even if it's a different color. Okay, so I use this one. Let's see, what else? I have a yellow one, but this is a green 8, so I can't put it on top. But this is a green 1. So the next card I can put down is a green 1. Why am I allowed to do that? Because it's the same color. So I use that one. Then I have a yellow 1. Why am I allowed to put that next? Well, because it's the same number. And then I want to get to the yellow 3. So yellow 3. Why am I allowed to put a yellow 3 on here? Is because it's the same color. At the end of your proof, okay, we're going to do it here so you can practice. It doesn't really look as nice on an outline, but usually on a yellow proof, or on a yellow proof, on the end of a proof, we put some kind of, as mathematicians, some kind of symbol meaning done. There's one symbol that, it's a Latin thing. I forget what it is all the time because I don't use it. So you can look it up if you want. I tend to just use a box, and then I put an X through it, saying I'm done. You can put a box and color it in, or I've seen just a box. Like I said, there's a 3-letter acronym. That's like a Latin phrase that means like you're done or whatnot. I saw it one time. I never used it, and so I forget it all the time. Anyways, I'm just going to put a box with an X through it, and that means I'm done. And there's your first UNO proof, or just proof in general. Right, so what we did was we started with a given statement, and I wanted to go through some steps to prove that I could get to yellow 3 based on the cards given to me. And I had to give a reason why I could put each card on top of the one before it. Right? I couldn't just say, oh, well, I just know it. No, you have to give the reason. Why does it work? Why is it true? Let's do another one. Let's do the next one. So let's see, with this one I'm given, got to move the screen a little bit, sorry. Or I guess it doesn't I move the screen, but it doesn't look like it to you. I'm given a blue 0. I want to prove a yellow 7. And I only have a red 0. And I have a red 7. Alrighty, so given, I have a blue 0. That's what's given to me. This one, maybe we should have done this one first because it seems a little easier, huh? Less steps. So let's see. In my hand, I have a red 0. Red 0. Well, because of the same number, I can put a red 0 next. The reason I'm allowed to put a red 0 on a blue 0 is that they're the same number. That's done. I can do a red 7 next. The reason I'm allowed to put a red 7 on a red 0 is because of the same color. And then let's see, yellow 7. Well, that's what I'm ending at, but why am I allowed to put a yellow 7 on a red 7? Same number, finished. Okay. Let's do this last one, and then we'll do a couple of algebra proofs. That's where the fun really starts. Algebra proofs, they're so fun. They're a little long, especially how I teach them. They're a little long, but they're super, super fun. Okay, let's see here. So last UNO proof, we're given a blue 0. So blue 0, we want to prove a yellow 7 once again. We have a blue 5. A red 0. A red 2. And a red 7. Let's see here. Now, there's a couple ways you can do this. Okay. Actually, I'm trying to see. No, there's only one way. But when I say a couple ways, some of you might get confused with blue 5. But anyways, we'll go with it. Blue 0, that's what's given to us. Now, I could put a blue 5 down, but once I put a blue 5, there's nothing else to interact with it. There's no other blues, there's no other 5s. I get stuck. I can't get to yellow 7. So I'm not going to use the blue 5. We never said you have to use all the cards. Right? In every theorem or every proof, you don't have to use all the theorems. Right? In fact, a lot of times you don't. It's impossible. So you don't have to use all the other cards or all the theorems. But I do know I can put a red 0 on for same number. I could put a red 2 on if I wanted. But what if I just go straight to red 7? I can do that because of same color. And then I can go straight to yellow 7. Which is same number, and I'm done with my proof. I'm at my proof. And notice I didn't use B5 or red 2. I didn't need to. That's another beauty about proofs. Is that a lot of times mathematicians, they're not proving new things. They're trying to make proofs quicker, or less verbose is the word that I had some college professors use. Verbose, meaning wordy. Anyways, in fact, there was one that, we won't get to, obviously, we don't talk about it, but it's called Euclid's fifth postulate. And people spent around 2,000 years trying to prove that you didn't need this one theorem to create geometry. And they tried to disprove it. They only wanted the 4 postulates instead of the 5th one. A postulate is like a, well, we're not going to get into that because the video will get too long. Anyways, it's kind of like a theorem, and they're trying to prove that you didn't need this one theorem to create geometry. And this is a really watered down telling of the story. But after 2,000 years, they figured out, nope, got to have it. Right? So people spent 2,000 years trying to prove or disprove a theorem when they found out they needed it. So a lot of times that's what happens, right, in mathematics is they're trying to make things simpler, right? Simplify, simplify, simplify. And either you can't, sometimes you can. So you don't have to use everything. Make it as simple as possible. Just make sure it's logical. All right, let's do some algebra proofs. We're going to use these properties of equality here. Okay, I'm not gonna go through these in the video. Try to keep it shorter. But each property gives you an example. All right, so just use those examples. All righty. Like I said, these can get a little bit long, but it's okay. They're fun. Okay, you're probably gonna feel like a lot of it is tedious. But remember, with a proof, you don't get to do anything in a proof, even in your head, without saying why on the paper. You can't skip steps. Okay. So this will be hard for some of you that like to skip steps. Okay, where am I? Oh, the back side. So let's see. I have 3x minus 7 equals 5. I want to prove that x equals 4. This is my given. Okay. So your very first step that you're thinking of, well, I got to add 7 to both sides. So let's do it. 3x minus 7 plus 7 equals 5 plus 7. I added 7 to both sides. Now, right here. Where's that? Addition property of equality says I can add a number, the same number to both sides. So I just did that. So this is the addition property of equality. All right. Now let's simplify. Negative 7 plus 7 is 0. So 3x plus 0 equals 12. There are little tiny steps that we'll be skipping because we don't have them on here, but that's okay. We're going to do as much as we can. So this, negative 7 plus 7, well, equals 0 right here where it says inverse. There's an example that says if you add a number and it's opposite or it's negative, you get 0. It's the inverse property. Okay, 3x plus 0 is 3x. Okay, now what property says I'm allowed to do that? Right here. See right here where it says a plus 0 equals a. Identity property. Whenever you add 0 to a number, you get the same number out. Identity. Okay. Now I'm going to divide by 3 both sides. Okay, that's the division property of equality. Right here, it just says that you're allowed to divide by the same number both sides of an equal sign. So division property of equality. Okay, 3 divided by 3 is 1. So 1x equals 4. Once again, if you look at the multiplication side, when you multiply a number by its reciprocal, or sometimes we call it inverse, it equals 1. So when you multiply two numbers together that equal 1, they're inverse. So inverse. 1 times x is just x. So whenever you multiply a number by 1, you get the same number out. That's the identity property. And we're done. We just proved that x equals 4. Now, like I said, especially even here, you add 7 to both sides, it equals 0. You're like, well, I normally just skip all this and get down to here. Okay, we've been allowing you, it probably hasn't helped you, right? It's kind of setting you up for failure for this proof stuff without giving proofs for it. But we've been allowing you to kind of do some of this stuff in your head and skip steps. Ain't going to work anymore. Okay, you got to show every single step, even the ones you do in your head, and why you're allowed to do it. Now, you might be wondering, do I have to memorize all this? No, you do not. You will get this on the quiz. You get this exact paper on the quiz. So you do not need to memorize names or even how it works, right? There's examples here. You just need to know how to use it. Just know how to use it. All right, let's do another one. Oh man, I need a new eraser, don't I? Just kind of spreading everything around. I went to Walmart the other day to get a new eraser and didn't have any. I think I'm going to go get my, give me a second. This one. That helps a little bit, huh? Not really? How's it going?
Good.
Doing a video.
Oh, you
All right. Let's do 5 times x plus 12 equals 30. That's given to us. Well, first step, I got to multiply the 5 in. So 5x plus 60 equals 30. Distribution property. How do you spell distribution? Or I guess you can say distributed. I don't care which one you use. You can say distribution or distributive. I don't care. Distributive. Okay, distributive is just an adjective. Distribution is noun? Adverb? I don't know. Anyways, you can see right here. Distributive property. When you multiply into a parentheses, right? Everything on the outside of the parentheses is multiplied by everything inside the parentheses. Now, once again, we're going to subtract 60 from both sides. 5x plus 60 minus 60 equals 30 minus 60. That's the subtraction property of equality. Then we have 60 minus 60 is 0, so 5x plus 0 equals negative 30. This is the inverse property. Five x plus 0 is 5x equals 30. That's the identity. Divide 5 both sides. Oops, we need to go down another step. Sorry, that's my fault. 5x over 5 equals 30 over 5. That's the division property of equality. One x equals 6. That's the inverse property. And then x equals 6, right? 1 times x equals 6. Or 1 times x equals x. That's the identity. And we're done. So once again, making sure we write every single step out as best as we can, as much as you can. Got that last one here, and then we'll be done. Let's see. Ooh, a little long. That's all right. Proofs are a lot. So here we have 6r minus 3 equals negative 2 times r plus 1. Oh, when I printed this off, I forgot to put the then. This should be r equals... Oh, we'll figure it out. This is given to us. So we're solving. First things first, distribute. So 6r minus 3 equals negative 2r minus 2. That's the distributive property. Distributive. I'm going to add 2r to both sides. So 6r minus 3 plus 2r equals negative 2r minus 2 plus 2r. That's the addition property of equality. 6r plus 2r is 8r minus 3 equals 0 minus 2. That's inverse. Because negative 2r plus 2r is 0. 8r minus 3 equals negative 2. That's identity. Because 0 minus 2 is still negative 2. I'm going to add 3 to both sides. So 8r minus 3 plus 3 equals negative 2 plus 3. That's the addition property of equality. Negative 3 plus 3 is 0, so 8r plus 0 equals 1. That's inverse. 8r plus 0 is just 8r. That is identity. Divide everything by 8. That's the division property of equality. Kind of run out of space here, aren't I? I'm going to come up here. 8 divided by 8 is 1. 1r equals 1/8. That is inverse property. And then 1 times r is r. R equals 1/8. That is identity. And we're done. All right, so there's your, it's probably the longest it'll get. Lots of identities, inverses. That's pretty much what we use that a lot with solving. Anyways, that's it for this video. Remember, I'm here every day after school if you need help. Or send me an email and I can answer emails. That's it for the video.